Okay, in the previous lecture, we started with inverse Laplace. A lot of properties we have listed and also solved examples on. One or two properties are remaining on which we have to solve some of the examples. So we'll just recall the properties first of all. Laplace inverse of capital F of s plus a e to the power minus at, Laplace inverse of capital F of s. The property says that plus a you can remove and simply take the Laplace inverse of f of t. Everything will be fine. Laplace inverse of capital F of k into s. This is 1 upon k. Laplace inverse of, or simply small f of t by k, where f of t will be the Laplace inverse of capital F of s. Then Laplace inverse of d by ds of capital F of s. This is minus t f of t, because we know that Laplace of t f of t is minus d by ds of capital F of s. Then Laplace inverse of integral s to infinity capital F of s. As I have stated, integration is related to the division, multiplication is related to derivative. Next one, Laplace inverse of s into capital F of s. This is equal to f dash of t if f of 0 is equal to 0. And the last one, Laplace inverse of capital F of s upon s. Since there is a division on the right hand side, you must have integration f of u du. Limit is from 0 to t. These properties we have seen. We have solved example on some of the properties. Some are remaining. So I'll go for the example now. Example. Find the inverse Laplace transform. Find the inverse Laplace transform of, first one, 2s upon s square minus 4 whole square. So what I can observe is the derivative of s minus 4 square is in the numerator. Okay. So Laplace inverse of, I will assume that, suppose 2s upon s square minus 4 whole square is equal to f of t. Suppose this is f of t, then Laplace inverse of integration s to infinity 2s upon s square minus 4 whole square ds will be equal to, integration is related to the division f of t upon t by the this one. So what is the integration? Laplace inverse of, so if you put s square minus 4 as t, so what we will have in the numerator, dt upon t square, right? So as I said, s square minus 4 derivative is in the numerator. So if you put s square minus 4 is equal to t, so I will write it down here. So s square minus 4 is equal to t then 2s ds will become dt. What about the limits? If s as it is there, then t will become s square minus 4, and later at infinity things will become infinity. So what is the integration of 1 upon t square dt? So this is minus 1 by t, right? So what I'm going to write here is minus 1 upon s square minus 4, limits from s to infinity is equal to f of t by t. Please check the calculation.
सर आवाज अडकतोय तुमचा आवाज नाही येत क्लिअरली.
आवाज अडकतोय. बरं आता येतोय का?
हो येतोय सर. आणि सर बाकीचे स्टुडंट काही स्टुडंट ऍड नाही होते. त्यांच्याकडून ऍड नाही होते. ओके.
प्रज्वल वाघ. बरं. बाकीचे स्टुडंट जे आहेत ना तुझे मित्र त्यांना सांग वेळेवर यायला. हे नंतर परत लेक्चर सोडून त्यांना ऍड करत बसायला डिस्टर्ब होतं ना सगळं. So this is equal to, so Laplace inverse of, when you put infinity it is 0, minus when you put s, that will be minus 1 upon s square minus 4, bracket complete, is equal to f of t by t. So this is Laplace inverse of 1 upon s square minus 4 is equal to f of t by t. Now Laplace inverse of 1 upon s square minus 4, which is sine of 2t, sine h of 2t, sine h of 2t divided by 2 is equal to f of t by t. So f of t is equal to t sine h of 2t divided by 2. This is our final answer. So one example in the previous lecture we have solved where in derivative was there. Now we have solved where integration is there. So solve one more
सर परत
example.
एकदा रिपीट करता का?
काय
एकदा रिपीट करता का सर?
काय
सर स्टार्टिंग पासून आपलं फाइंड द इनवर्स रिप्लेस आहे ना त्यापासून आणल्या रिप्लेस.
काय कळालं नाही मला, सांग ना तू.
एक्झाम तर मला काही समजत नाही ऍक्च्युली मी नवीन जॉईन झालोय आज.
हा आजच जॉईन झालाय.
हो.
एक मिनिट थांब फक्त.
हो.
Prajwal, what is the derivative of s square minus 4 whole square?
सॉरी सर.
Derivative of s square minus 4 काय आहे?
नाही सांगता येणार सर.
नाही, हे शिकवत नाही मी, हे आधीच विचारतोय, म्हणजे ते यूज केलंय ना इथे. ते जर आलं तर पुढे हे समजेल, नाही तर ते समजणार नाही.
ओके ओके सर.
डेरिवेटिव्ह ऑफ एस स्क्वेअर मायनस 4 काय आहे? 2s, बरोबर
हो.
है ना. तर एस स्क्वेअर मायनस 4चं डेरिव्हेटिव्ह वरती आहे, म्हणून आपण काय केलंय की प्रॉपर्टी यूज केली. हे बघ, याच्या समोर एरो केली आहे प्रॉपर्टीच्या समोर. सो
हो. ओके.
इंटिग्रेशन ऑफ, तर ती प्रॉपर्टी यूज करून नंतर इंटिग्रेशन केलं असं.
ओके ठीक आहे.
ओके. Next example. Find the inverse Laplace transform of s upon s square plus a square whole square. So what we do is, what we need to find is Laplace inverse of s upon s square plus a square whole square. So I assume that suppose it is f of t. Okay. So what do I observe? Laplace inverse of s upon s square plus a square whole square. So in this, d by ds, we know that 1 upon s square plus a square. What is it? It is minus 1 upon s square plus a square whole square, and by chain rule, derivative of s square plus a square is 2s. So what do I have? Minus 2s upon s square plus a square whole square. So this I know. Okay, so by the property Laplace inverse of d by ds, capital F of s is actually equal to minus t times f of t. This is our property. So we know that Laplace inverse of 1 upon s square plus a square is actually equal to sine of at by t. This is the property. The at by a. This is the property that we have proved. So Laplace inverse of d by ds of this thing, 1 upon a square plus a square, by the theorem needs to be minus t sine of at by a. Now, once we have this d by ds, 1 upon s square plus a square is equal to minus t sine of at upon a, what do we do further is we differentiate. Once we differentiate this, what we will have? Laplace inverse of minus 2s upon s square plus a square whole square, and this is equal to minus t sine of at upon a. So in order to get the original thing, which is s upon s square plus a square whole square, what we do is we adjust this minus 2 on the right hand side. So the final answer in this case will be minus sign will get cancelled out and 2 will go into the denominator. We know that the constant can come outside the integration. That's why Laplace inverse of s upon s square plus a square whole square will be equal to t sine of at divided by 2. Next one, example, Laplace inverse of 1 upon s into s plus 2. There's one more property which is Laplace inverse of capital F of s divided by s is equal to integration 0 to t f of t dt. What do I mean by this? Small f of t is integral 0 to t. Small f of t is Laplace inverse of capital F of s du actually. Okay. So there is 1 by s. This Laplace inverse of 1 upon s into s plus 2 is actually 1 upon s plus 2 divided by s. So this is my capital F of s according to this property. So what is this going to be? This is equal to integral 0 to t Laplace inverse of 1 upon s plus 2 du. Laplace inverse of 1 upon s minus a is e to the power at. So this will be e to the power minus 2u du. So this is e to the power minus 2u divided by minus 2, limit from 0 to t. So when I put the upper limit, I will have e to the power minus 2t by minus 2 minus. When you put the upper limit, e to the power 0 will become 1 minus 2 as it is. So the final answer is e to the power minus 2t minus 1 upon minus 2. So which can also be written as 1 minus e to the power minus 2t by 2. The final solution. Look, the in whole of the chapter, your properties are very important. I mean, you should be able to remember what is the Laplace transform. You should be able to remember what is inverse Laplace transform. Also, you should uh, understand the notation capital F of s, capital F of s plus a, and so on. We have solved enough number of examples so that you can understand how to use these properties. For MCQs, I mean, in that thing, there's 2 marks problems. All of them will depend on how you use the properties. Okay. So Laplace inverse of 1 upon s square plus 4. Again, there is 1 upon s. So for 1 upon s, what we do is integration 0 to t and Laplace inverse of whatever is remaining after 1 upon s, it is s square plus 4 du. We know that Laplace inverse of 1 upon s square plus 2 square, which is sine of 2u, sine 2u divided by 2 du. This is by the formula. So 1 by 2 will come outside, integral 0 to t sine of 2u du. So 1 by 2 integration of sine 2u is minus cos 2u, limits from 0 to t. So the answer is 1 by 2 minus cos 2u by 2. Sorry. So that will be minus cos 2t by 2, minus will become plus, we put 1 0 will be 1 by 2. This is our final answer. Okay, so that's it. This many examples will solve, and now what we can do is we can go to the next and very important point in this chapter, inverse Laplace transform, which is inverse Laplace using partial fraction. Partial fractions is something that you have already studied. So can anyone remember which where you have studied this partial fraction, or what is it?
By shortcut method, YC.
While shortcut method, exactly. Okay, so you have done this in your diploma as well while solving the integration. Okay, and where I'll study this, I'll teach you this partial fraction in detail today. Is the reason because it is a very important tool to find out integration as well as the other things. So partial fraction is something when you have a polynomial f of x upon g of x. Both of them are polynomial. F of x comma g of x are polynomial. These are polynomials, and partial fractions can only be used when degree of f of x is less than degree of g of x. Okay, so we know that a polynomial degree of a polynomial in the numerator has to be smaller. In that case, I can use partial fraction. And there are different cases, like say if you have k upon x minus a, x minus b. By partial fraction, how do I have to write it as a upon x minus a plus b upon x minus b, small b. So what do I have in numerator? Two factors, x minus a, x minus b. So by partial fraction, how can I write this? a upon x minus a plus b upon x minus b, which means that denominator I can separate. Similarly, if I have ax plus b upon x minus alpha, x minus beta, then again this term I can write as a upon x minus alpha plus b upon x minus beta. So partial fraction tells me that this kind of expression can be separated in this manner, and later I will find out the values of a, b by some other method. Okay. Third type is, say if you have ax square plus bx plus c upon x minus alpha, x minus beta, x minus gamma. So this thing I can write as a upon x minus alpha plus b upon x minus beta plus c upon x minus gamma. Look at each and everything. I mean, on the left hand side, in the first one you have constant in the numerator, degree of denominator is 2. So I've used the partial fraction. In the second one you have degree 1 polynomial in the numerator and degree 2 polynomial in the denominator. So again I have used partial fraction. I have separated it. In the third one, degree of numerator is 2, whereas degree of denominator is 3. So again I have used the partial fraction. I have separated it. These are the patterns. Okay, how I can separate. What happens if you have ax plus b x minus alpha square bx plus c upon x minus beta. So what has happened now? Previously, all the factors in the denominator were of degree 1. Now what has happened is x minus alpha is of degree 2. So in such type of cases, what we do is we repeat this x minus alpha. So a x minus alpha plus b upon x minus alpha square plus c upon x minus beta. Okay, so if some of the root is repeated, whatever number of times it is repeated, that many times this pattern is to be followed. Take a screenshot of it or write it down. So once we have separated this, look at this Laplace inverse of this term I can find out, Laplace inverse of this term I can find out. Similarly, Laplace inverse of the right hand side in each of the step I can do it. Okay. So what we do is we will use the partial fraction, convert it to these form, and then I will take the Laplace inverse. So I hope that partial fractions is clear to you now, so that I can go for the examples. Example: find the inverse Laplace transform using partial fraction. Using partial fractions. The first one, 3s plus 7 upon s square minus 2s plus 3. Sorry, minus 3. So Laplace inverse of 3s plus 7 upon. Can you factorize the middle term? So what we will have? S square. So you need addition to be minus 2 and product to be minus 3. So minus 3s plus s minus 3. So this I can write it down as Laplace inverse of 3s plus 7 upon s common. So you will have s minus 3 and s plus 1. Please check the calculations. So if you look at the form, what is the form? Ax plus b upon x minus alpha, x minus beta. This one is the form, and previous slide we have seen that this can be written as a upon x minus alpha plus b upon x minus beta. This is the form by partial fraction. So by partial fraction, by partial fraction, what I can do is 3s plus 7 upon s minus 3 s plus 1. This I can write as a upon s minus 3 plus b upon s plus 1. So you do the cross multiplication on the left hand side. So what we will have? 3s plus 7 upon s minus 3 s plus 1. This is equal to a into s plus 1 plus b into s minus 3. Upon what do we have? S plus 1 s minus 3. So this 2 gets cancelled out. This becomes 3s plus 7 is equal to a into s plus 1 plus b into s minus 3. So now what I'm going to do is I will put the value of s in such a manner that one of the bracket becomes 0. So if I put s is equal to 3, put s is equal to 3, then what will happen? 3 into 3 is 9, 9 plus 7, it is equal to 16, is equal to 3 plus 1, which is 4a plus b into 0. So what do I got? A is equal to 4. Let's check the calculations. Similarly, I will put s is equal to a minus 1. Then why I'm putting this values? One of the bracket, my target is to make one of the bracket 0. So what I have? Minus 3 plus 7, it is equal to 4, is equal to b into minus 4. So b turns out to be minus 1. Is there anyone having problem up to this? So from this, what I have got? 3s plus 7 upon s minus 3 s plus 1. I've written it as 4 upon s minus 3 minus 1 upon s plus 1. And so Laplace inverse of 3s plus 7 upon s minus 3 s plus 1 will be equal to Laplace inverse of 4 upon s minus 3 minus 1 upon s plus 1. So Laplace inverse will separate over subtraction. 4 will come outside. Laplace inverse of 1 upon s minus 3 is e to the power 3t minus Laplace inverse of 1 upon s plus 1 which will be equal to e to the power minus t. Take 2 minutes, read it carefully. If you have any problem, you can ask. Yes,
हॅलो सर.
yes, go ahead.
सर आपण ए ची व्हॅल्यू
Huh,
4 आली बरोबर. ए ची व्हॅल्यू 4 आली.
huh,
तर त्यानंतर जे पुटले त्याच्यानंतर खाली काय आहे ते बी लिहिलंय का ते
huh,
बी
B
इज इक्वल टू
लिहिलं.
-1.
Yes, B, it is B. Huh. Okay, next example. Find the inverse Laplace transform. Find the inverse Laplace transform of 3s plus 5 upon 4s square plus 12s plus 9. So in this case, if you look at the denominator, 4s square plus 12s plus 9, you cannot factorize this. You take 4 common, in bracket you will have s square plus 3s plus 9 by 4. You cannot factorize the middle term in this case. Previously, I mean to say, by factorization, I mean to say I cannot write it as x minus alpha s minus beta form. You cannot convert it to this because if you take delta over here, b square minus 4ac, 12 square minus 4a into c. 12 square 144 minus 16 into 9. So 144, 16 into 9. So it turns out to be 0. B square minus 4 AC, yes. So that will turn out to be 0. So if I find out the factor, it create some of the problem. So what we have to do here is we will convert it into a complete square. What do I mean by completing square is half into coefficient of x whole square. Okay. Completing square matlab you need to convert it to the form a plus b whole square. A plus b whole square. Okay. So a is nothing but 2s whole square plus what is your b? 2 into 2s. So the 4, if there is 3, then the thing will be done, and this is 3 square. So look at this. The denominator is turning out to be a complete square. So what do we do here? I will make the same thing in the numerator also. So Laplace inverse of 3s plus 5 upon taking 4 common. What do I have? S square plus 3s plus 9 by 4, which is equal to Laplace inverse of, in the numerator, I'll adjust it later. First of all, in the denominator, what I will do is s square plus 3s plus 9 by 4 is actually s plus 3 by 2 square. So what I have to do is I have to convert the numerator also in the form of s plus 3 by 2, because I have to use the property Laplace inverse of capital F of s plus a is equal to e to the power minus 80 f of t. Okay, I have to use this property, and that's why I'm converting it to the form capital F of s plus a. So now in the numerator, what I will do is I'll write it down as Laplace inverse of 3 common in bracket. Uh, Anyway, I'll not make the bracket first. S 3s plus 5 plus what I will do is 3 by 2. I need s plus 3 by 2 in the numerator. So 9 by 2 minus 9 by 2. I've added 9 by 2 and subtracted 9 by 2, and in the denominator s plus 3 by 2 square. So Laplace inverse of, in bracket, from the first and the third term I can take 3 common. What I will have s plus 3 by 2, and I can add the second and the fourth term. So what I will have 10 minus 10 minus 9, which means that plus 1 by 2 upon 4 into s plus 3 by 2 square. Anyone having problem at this stage? Now you separate the denominator. So what we have, Laplace inverse of 3 into s plus 3 by 2 upon 4 into s plus 3 by 2 square. 1 by 2 being constant can come outside. Laplace inverse of 1 upon 4 into s plus 3 by 2 square. Now Laplace inverse of capital F of s plus a. So 3 by 4 will come outside, e to the power minus 3 by 2 into t, and Laplace inverse of s upon s square, plus 1 by 4 will also come outside. It will become 1 by 8, e to the power minus 3 by 2 into t, Laplace inverse of 1 upon s square. So this is 3 e to the power minus 3t by 2 by 4. 1s will get cancelled out. Laplace inverse of 1 upon s is 1, plus 1 by 8 e to the power minus 3t by 2. Laplace inverse of 1 upon s square. So t raised to 2 minus 1 upon gamma of 2, which is 1. So e to the power minus 3t by 2 common in bracket 3 by 4 plus t by 8. And this is our final answer. Next example. Find the inverse Laplace of 3s plus 1 upon s minus 1 s square plus 1. Look, for the second one, you cannot put the factors. Moreover, degree of numerator is 1 and degree of denominator is 3. So, of course, you can use the partial fraction, but this degree 2 won't be reduced. So, in that case, what we do, just observe. So, Laplace inverse of 3s plus 1 upon s minus 1 and s square plus 1. So, I will mention by partial fraction. So, if you have ax plus b upon x minus alpha, and later you have mm, a1x plus a2, and the denominator you have ax square plus bx plus c. This is x minus alpha. So what do I mean by this ax square plus bx plus c is this cannot be reduced. Cannot be reduced. Okay. अगर reduce किया तो it will go into the complex form, and in that case the partial fractions are a upon x minus alpha plus bx plus c upon ax square plus bx plus c. So whenever you have a term in the denominator such that it cannot be reduced, I mean to say x minus alpha, x minus beta form mein, you cannot write it down. In that case, the partial fractions are given in this pattern. So in that case, the numerator is bx plus c for that not reducible term. So by partial fraction, this 3s plus 1 upon s minus 1 s square plus 1. This I will write it down as a upon s minus 1 plus bs plus c upon s square plus 1. So once we have done this, again I can do the cross multiplication. I can simplify. What is my task? I need to find out the values of b, c and a. Once I'm done, then I can find the inverse Laplace. So doing cross multiplication, I'll get 3s plus 1 is equal to a into s square plus 1 plus bs plus c into s minus 1. So I can collect the coefficients. 3s plus 1 is equal to a plus b into s square. Okay. Or simply in this case, what I will do is I'll put the values of s. So put s is equal to 1. So what we get, this term will become 0. Okay. So what do we have? 1 minus 1, 0. So 4 is equal to 2a. So what we get? A is equal to 2. So 3s plus 1 is equal to 2 times s square plus 1 plus in bracket b into s square plus cs minus bs minus c. So b plus 2 into s square plus c minus b into s, and the last one 2 minus c is equal to 3s plus 1. So b turns out to be minus 2, and b c minus b is equal to 3. C plus 2 is equal to 3. So this gives me c is equal to 1. So what we have, Laplace inverse of 3s plus 1 upon s minus 1 s square plus 1. This turns out to be 2 upon s minus 1 Laplace inverse of plus Laplace inverse of minus 2s plus 1 upon s square plus 1. Yes, anyone? How can we find out the second Laplace inverse? So separate it. By separating the denominator in the second one, what we will have, I'll take minus 2 outside. Laplace inverse of s upon s square plus 1 plus Laplace inverse of 1 upon s square plus 1. For both of them, you have the formula. So I will stop here, as I think you can solve it now.
Yes, sir.
Okay, fine. We'll stop here now. Thank you, everyone.
Sir,
Okay,
what is
sir.
the syllabus
Okay, sir.
for the midterm?
For midterm, you will have our LD and Fourier transform.
Okay, sir.
Prajwal, you have anything?
सॉरी सर ऐकू नाही आले.
काही विचारायचं आहे का?
समजलं सर.
ओके, ठीक आहे.
ओके थँक्यू सर.